This is question 2 of the coordinate geometry revision worksheet. In part A, we're being told about a circle, K1. We have its equation. We want to find its centre and radius. Just to note the format in which they're giving us the equation of the circle. And from that, I can get G, F, and C. And I can use those to get centre and radius. So I have 3 minus 1 for my centre and 5 for my radius. In part B, I am told a little bit more about circle K2. I'm told what its radius is, and I'm told that its centre can be written as minus G minus F. And I want to show this equation holds up. 3 plus G squared plus F minus 1 squared equals 225. I'm going to draw a quick sketch of what's going on. Note that they told me back at the beginning of the question that the two circles touch externally. So I've got my two circles, their centres marked in, but I also know about their radii. First of all, I know that if the two circles touch externally, that the radii and the point of contact are collinear. So this is a straight line here. And since I know the value of each of the radii, I know that the total distance between those centre points is 15. So I'm actually just going to use the distance formula to establish the statement here. So you can see that I'm almost there already. All I have to do is a little bit of rearrangement and also get rid of the square root by squaring both sides. And that'll give me the desired equation. In part 3, they want us, or in part C I should say, they want us to use the information to date to find possible equations of K2. At this point, information in part B becomes relevant. We're told that the centres of the circles lie on this line, 4x plus 3y minus 9 equals 0. And the point in K2 is minus G minus F. That's my centre point. So what I'm going to do is use that information, the point and the equation of the line, to try and get this point and really G and F in terms of one variable as opposed to two. So if I know that the point is on the line, I'm just going to sub it in and I'll do a little rearranging to get G by itself. I got G equals 9 plus 3F over minus 4. And now I'm going to go back to this equation that I have from part B and I'm going to sub in this statement for G and then I'll have an equation in one variable. So I've subbed that in. It's very tempting at this stage to times across by minus 4, but don't do it because I'm inside in a bracket being squared. It could end up being a bit messy. It's much better at this stage just to do your squaring out and then worry about fractions in a minute. Take your time with your squaring in this. That's my first bracket nearly squared out. So I squared the first guy, first by second by 2. I squared the last guy. Watch out there that you have to square out that whole numerator over 16. And then the second bracket just is pretty simple. F squared minus 2f plus 1 equals to 225 at the end. Bit of tidying up required now for this. I just tidied up this fraction a bit first of all, and then I think multiplying across by 16 could be a good plan. And I'll tidy this up then into a quadratic. So there's my quadratic. I can divide across by 25. And this actually factorises quite nicely, or you could decide to use the minus b formula, which is also fine. And I'll get two possible values for f, which are minus 11 and 13. And of course, I need to know what g is going to be as well. So for that, I'm going to go back up to this little equation earlier on. G equals 9 plus 3f over minus 4. That's going to give me a value of 6 for G, or minus 12 when f is 13. So from that now I've got two possible centres. Don't forget from the log tables that the centre is minus G minus f, which gives me two centres of minus 6, 11 and 12 minus 13. And they did tell me earlier in the question that the radius was 10. So now I can set up my two possible equations. The first of which is x plus 6 squared plus y minus 11 squared equals 100. And the second of which is x minus 12 squared plus y plus 13 squared equals to 100. And those are my two possible solutions for that question.